This is for Chapter 3 in Ch3 books. We've been talking about strings for a while. We're going to go into a little bit more information about strings in this chapter. So a string, of course, is a sequence of characters like the text Mary that can be stored in a variable. It's not an integer, although a string can contain integers, and a string can contain floats, but they're a different type of variable and there are limitations on what you can do with those. So you can concatenate strings, you add variables like integers and floats. A string literal is a string value specified in the source code of a program. So anything that you put in quotes is a string literal, and the string literal could be stored into a variable. A sequence type, a type that specifies a collection of objects ordered from left to right. We're going to see a lot of sequence types in Python, so this is going to be a pretty important concept. Here we see a sequence type that's actually a string, which a string is. It has indices for each one of the letters or numbers in the string, anything stored in the string. So the index for the first one always starts with 0, and that's fairly typical through any programming language, especially any one that I've seen in my history of programming, which is about 40 years worth. So type a string below, and in here you're able to type more strings. You can see that show up. If I type some O's, we talked in last class that there was a problem if you had leading zeros. So if I type some leading zeros, those can be stored in a string, and this is no longer an integer if it's being stored in a string, however. Mad Libs were invented in the 50s. You can buy books that you can fill in for Mad Libs. You often see these done at baby showers and bridal showers. So a sequence of words is asked for, and here they're saying let's put in the words brother, burritos, macho, and day. So usually it's asked for adverb or adjective or number or something like that, something to eat. So you put in these different things, and when you run it, it's going to enter a type of a relative, and it's going to print it out. And enter, skip a line, go to the next line. So I'm putting instead of putting a backslash in, they did a free print line in here. And then it's going to enter a type of food and go to the next line and enter an adjective. So you can see here. So just like the Mad Libs were done originally in the 50s. And I think the first ones I saw were in the early 70s. So when you spit this out, it puts those variables in. Now you want to think about how you could do this with a formatted statement. So how would you do this using a formatted statement? Those two ways, both writing them this way with the actual variables put in, and a formatted statement will be required for the test. This doesn't ask for a formatted statement, but I want to go ahead and put one in. So this will be all on one line. So I'm going to move relative, food, adjective, and period. So if I change the string that was there, put a triple quote at the beginning, a triple quote at the end, put placeholders for the 4 variables that I'm putting in. It's these 4 here. Brother, burritos, macho, day. And the dot format with a list of variables afterwards. So you should be able to format with several print lines if you wanted to get something printed like this, or with just one print that extends over several lines. Both of these are adequate programming. You will need to do both on the test. The next thing we talk about is the length of a string. So you put length with something inside. This is actually a function. See the word function? This keeps showing up. Print is a function. Length is a function. Format is a function. So you'll have some word, and then maybe not an English word, but a programming word. You'll have some word like this, len, which is short for length, with open parentheses, and sometimes you put stuff inside and sometimes you don't, and that's true with the print statement too. You can end up with an empty line if you don't put anything on the inside of an empty print. So here they're looking at the length to get the length of a string. Notice here they're showing you another way to go to another line, so you might try this way to go to another line. Revisiting our previous Mad Lib example, I could put quotes and put a backslash here, quotes with a backslash, quotes with no backslash here because I'm finished. This whole thing that I have shaded is one string. So it's one string. It's kind of like concatenating a string, but you're using it from line to line. Notice that I had to put the spaces in at the end to make sure that I have spaces over. Now this one does a word wrap, where the previous one that I did not do a word wrap. It looked a little different. This would end at each line at the where you went to the next one. So the triple quotes will give you exactly the paragraph that you want. Very helpful if you're doing poetry. And the ones with the backslash at the end where you have single quotes on each one will not take you to the next line. It word wraps. Well, it does take you to the next line, but it word wraps wherever it thinks you need to be breaking lines. So we have indices. That's what we talked about first for this section. We also are able to pull indices out like this and print them. So we can print the character at the 0, which is the A, and the 1, which is the B. The 25, well, there's 26 alphabets here, but the first one started with 0, so 25 should be the Z. So 0 through 25 instead of 1 through 26. It takes a little getting used to, but it's not too bad. So what would happen if we wanted the length of the alphabet, LEN with alphabet in there? That would actually be 26. So don't confuse indices with length. A length is how many characters there are. Indices start with 0, and then you go all the way up to the 1 minus the length is what you have. The next little program they have at 3.1.2 is string indexing. And it says letter 2 of the alphabet is C, so I'd rather have this say index 2, or maybe type index in Python, index 2 of the alphabet. And remember that the commas with the quotes actually give you a space in here. Don't forget that. So I've run this now. I see that index 2 of the alphabet is C. That just makes more sense to me. I ask you to try things like -3 and run it. So -3, this would be 0. This would be -1, -2, and -3. These would be these. So -3 would be going back through the string. So if you use negative indices, you get back through the string. They suggest I try some negative numbers, but there are some that aren't going to work. So -26. The length of the string is 26, so I can go back as far as -26. We'll try that. -26. Run that. And that gives me the -26 of the alphabet. So I can use all the way back to -26, but if I put in a +26, that's too far. So I can go from -26 to 25, and that does the alphabet twice, going backwards or going forwards. 3.1.3 is just a cautionary. You can't reset any part of a string using this index, this bracket and index. So you kind of think of a string as an indexed group here, but you can't go in and just change one of the letters. If you wanted to change one of the letters, you'd have to change all of them like this. Of course, you wouldn't really have to change all of them if all you want to do was change A and B. You could leave the rest of them exactly how they were. Concatenation we've already talked about, so here's another little example of concatenation. Then you have some string basics that you're going to want to do here. Remember that you need to do an enter if you're going to the next line. If I start this, CID, enter, and check. And that looks fine. So just remember you have to put an enter in there when you go to the next, to be able to do the next. This 3.1.2 looks incredibly simple compared to some of the things we've been doing because we've been working with these a little bit more. They want you to take these person name and person age and actually have them have input. So we have user input for the person age, user input for the person name. So you're just putting 2 lines of code here. Note that we could rewrite this using a formatted print statement. 3.1.3, you're concatenating, putting plus signs in between strings. If you want spaces, you're going to have to add a space in with the plus signs. So you're going to write 2 statements to read in the values. That's an entry. So my city, my state. So these 3 I'm filling in. Copy those down. I'd recommend after your solution goes here is where you put this, and that's where I'd like you to put it on the test. So anything that I give you like this, I'd like you to keep and put anything you're putting in after on the test. So remember that this would be an input and they say blank. So do not provide a prompt. That means a blank input. And then my state, whatever that needs to be. And then the log entry is going to be a concatenated current time. What does it say? Current time, my city, my state. So I need current time plus my city plus my state. Now they've said the values should be separated by a space. These are not separated by a space. When you concatenate, it jams everything together. So you're going to have to put in a space in here. The easiest way to do that in programming is just put a space in like this. So you got current time, and then you're going to put a space, and then you're going to my city, and then you're going to put a space. So you're going to do exactly the same thing here. So there's a little bit of a hint of what you need to do in order to get the concatenated string in. 3.2 is an exercise in concatenating, especially with things like strings and integers put together. So you're going to enter 2 words and a number and play with them to come up with a formatted password. So here we have yellow, daisy, and the number is 6. Yellow, daisy, and 6 is what you want to print out. So it's pretty specific what you're supposed to do. You're just asking for a couple of strings and an integer. And I recommend integer even though it doesn't say integer here, because the example uses an integer. When you go to print out the passwords, the first passwords and the second passwords, first one's not going to be a problem at all, but the second one involves integers and strings. So there's a way to convert an integer to a string. It's the str function, so I recommend you use that. Lab 3.3 is an exercise in characters and spaces. So note here that the arrow really only has 1, 2, 3 different lines, and then the 2 is the same as 4, and 1 is the same as the 5th line. So you can think of that when you're printing these out. You can use any of the characters on your keyboard here. You don't have to use a star and a hashtag. I tried an ampersand and a $sign, and I end up with one that looks like this. 3.4 lab is wanting you to take an integer input, that's a phone number, and putting out the actual formatted phone number like this. So all you're taking is an integer input. You're going to use the // like if I use that // with 1,000, it'll take off 3 decimal places. So this says the shifting the desired amount. So if I put 1,000 in, that's 3 decimal places. If I put 1,000,000 in, that would shift it 6 decimal places. 1, 2, 3, 4, 5, 6. So that'll help you get rid of some decimals. And then of course the percent to get the desired rightmost digits. So if you wanted these 4 digits here, you do percent 10,000, and it would give you those 4 digits. Actually, it's these 4 digits here. Percent 10,000 will give you the last 4 digits. Python has several structures for storing values, especially if you want to group them in some way. So if I wanted to store all of my relative profile data, I could put it in one container with a bunch of strings. Well, container here is just a construct to store values. A list is a particular kind of container, and it has brackets, not like the string did. The brackets in a string access each character in the string from 0 to 1 minus the length of the string. Here a list is going to access each element in the string. So if I had my profile, I would have my name, my first name, my last name, my telephone number, things like that would be in the list. So an element of the list is a list item, and the index is just like you did with the string, starting with 0. So the first element in your list is going to start with 0. One of the easiest ways to create a list is just to have a variable like this, and notice it doesn't say whether or not it's a list. It says equals and then shows you a list. So bracket with the elements one right at the other putting in will work just fine. So if I run this, it should print out my names, and it's good to run it because you can see exactly what it's going to print out. So print names, it looks like this. I could also have it print one of the indices. So if I come back over here, I can put print names bracket 2. So 0, 1, 2 should print Jean. And we'll run that, see how that works. And that printed Jean. So if you write print names, it prints the entire list with the formatting that you had in it. And print names 2 would give me the precise element in the second index, which would be 0, 1, 2. They ask you to add your name here, so you can add your name and see what the 3.5.1 challenge is real short. It just wants one little line in here making that list. So you want to make the list, and that's the name of the thing it's going to be, the thing with the brackets, and then those names in it. Unlike the string, you can update a list element. You can rename one of the list elements in here. So if you accidentally made a typo when you put something in, maybe I wanted to change my password, that'd be part of my profile, I could go into my index and change my password. Or if a female got married and took her husband's last name, she could go in and change her last name. The system would do that for them. So it's just taking the element, this would be element 1, that would be 12, right? And rename it as be -28. You can see that it actually did that. A method instructs an object to perform some action is executed by specifying the method name with a dot symbol. We've seen several methods already. We did the dot format, and we did the math dot, square root dot fabs, and dot pal. So you want to think about any of the times that you see a dot here, it means you're working with the method. The thing right after it is the method. Append is a method that the list used to add new elements to the list at the end. The elements can be removed using the pop or remove method, and we're going to play with those in the next couple of exercises. So you can add and remove elements with pop or append. Append is going to put it at the end. So they show you if you have this list and you append ABC, it's going to be at the end there. If you pop 1, it's going to pop the element at the first index, which would be BW. That's index 1. The first index actually is index 0. And then here it says remove ABC, so it would remove ABC from the list. And if you have more than one occurrence, you want to work with that, because sometimes this will remove every occurrence of that from the list, and it might not be what you want. So looking down here at the notes, it specifies it's going to remove the first element with the given value ABC. So things like print are functions, and the length here would be a function where you're putting the list on the inside. So that's a function. A method is like the math methods, math dot. So you have to go into the math class and use those methods. So here, len is a function. It finds the length of the list. Min you can find on the list, and max you can find on the list. If the list is all strings, then you'll be looking at the minimum in a list according to the Unicode values that we saw in the last chapter. So alphabetical order is capital letters and then lowercase, and numbers are before the alphabet. So if you wanted to find a particular value in a list, you could use the method, whatever your list name is, dot the index of that value, and it will return the index of the first element who has that value. And then the list.count, count the number of occurrences of the value in the list. It will tell you how many times you have that value in your list. This could be helpful if you wanted to pop all those values off, so that you could do one at a time, popping them off. 3.5.2 works with two lists of numbers. We have midterm scores and final scores. And they're going to combine the scores in a particular way, and here it suggests that you should try enhancing the program by calculating the average midterm and the final scores. Notice here that the length function is being used on a list to get how many elements are in that list. So that tells you how many you're going to have to divide by. So you're going to have to add all these scores up and then divide. I put a line of code in here with the sum of the midterm scores. So you have the length, and you also have a function called sum. Length is a function, sum is a function that you can use to determine what the actual averages are. That's what they're asking for here. remember here that the length is actually how many there are here. It's a count. 1, 2, 3, 4, 5, 6, 7. The length is a count of it. The indices would only go to 6. 0, 1, 2, 3, 4, 5, 6. So be thinking about that as you're going through here. Don't let it trip you up. Length is actually how many are there, starting with the number 1, counting numbers. A tuple is another kind of container. You put parentheses in it. You cannot change the elements of each one of the elements in a tuple. So if you have something you're putting in that you know is going to be that every single time, you could use a tuple. It is immutable. It does support the length, the indexing, and other sequence types of functions. You just can't replace any of its variables, so it's more like the string than the list. Lists are used more often, but if a programmer wants to be sure that nothing gets changed in a particular container, then they might use a tuple to do that. And I often say tuple instead of tuple, because if you say sextuplets, that you have the other sound for U there. So tuple or tuple. Here's tuple, and this would be tuple. So either one works. So to make team names as a tuple here, the only difference you'd have between the list and the tuple is that you're gonna initialize it with parentheses. Everything else is used exactly the same way as what it was with a list. A list is mutable, where a tuple is immutable. You can't change individual ones in it without changing the whole thing. So all you want is one line of code in here that says Rockets, Raptors, Warriors, and Celtics with parentheses and commas in between and quotes where you need them. So far we have a string, a list, and a tuple or tuple. Now we're going to add named tuples to that. A named tuple is a package, and it has to be imported. And it's part of a larger group, which is called collections. So from collections, I'm importing the name tuple. So this is a little more complicated than the import math. The way this works is that you have a name tuple that has what you're going to call any of the variables. So like here, car, I'm going to call Chevy Blazer. And then you have 1, 2, 3, 4, 5 different elements in a list that you're making, a tuple actually, because this is immutable. So in this tuple, you'll have a make, model, price, horsepower, and seats for each one of the cars that you build. So you can take this car name tuple, see, it almost looks like a function that I'm putting elements into, that I'm putting variables into. When you print them out, they print the variable name and what is in that variable for that particular car. So the Chevy Blazer, you can see all the different things that come, the different elements that were put into that print statement. If you want to get one of the elements out of a name tuple, you have to use its variable name here. So Chevy Blazer.price would give you the price out. So this named attribute is simple to read than the index like this. So if you know what the variables are that you want to use, then it's going to be a lot easier to see things with indices like this rather than having to remember which place the index was at. The challenge activity in 3.5.4 is working with this end tuple. This is really easy, but the format is pretty severe, so you need to think about how the format is going in. So they want us to get rid of this. Your solution goes here. In this case, I am going to get rid of it. I need a parentheses, and I want each one of the things that it's going to be in my end tuple. So basically, the cam is going to be using this end tuple, so I'm going to need end tuple, named tuple, just like that. And then I have player, comma, and in brackets, I'm going to put the actual field names. So I went ahead and put those in. So each of these variables that are going in here are strings. The first one is where the placeholder is for Cam and LeBron. And then each of the others, this looks like a list with the brackets here. So the names of the fields, which is a little confusing here because the first thing we have is name, but the names of the fields are put in quotes and they're strings. And the name that you're going to put in for the actual name tuple will be the new variables you're creating from this name tuple list. Note down here you have the cam.name. It's going to pull the name out of here, cam.number, cam.position, and cam.team. It looks like the method format that we had before. We're not using index numbers because this is a named tuple. So you can use this method kind of format when you're trying to call particular values off of a list in a named tuple. Now a set is a different kind of container. So we've had strings, list, tuples, in tuple, name tuples, and now we have a set. And a set is a little different. This does not have an order. This is an unordered collection, and they have to be unique. So in any of the other things, you could have all kinds of things that are repeated all over the place. You have strings that are repeated, or numbers that are repeated, whatever. But in sets, you can't have repetition. It's just a list of things that are unique. It can be created using the set function, which accepts sequence type iterable objects, list, tuple, string, etc., whose elements are inserted in the set. So a set can be made up of list, tuples, strings, integers, floats. It can be anything. So those elements are inserted in the set. A set literal can be written using curly braces with commas separating set elements. So let's take a look here and see what that looks like. So this is saying make a set out of the characters in the list 1, 2, 3. Now I could just put the list name in here. I might have created the list somewhere else, but I can make a set out of those, and it'll put the unique characters from that set in there. These are unique already, so it puts all of them individually. No particular order. So don't think of this as being the first element in the set is 1 and the second element in the set is 2, because this is just a set with the numbers 1, 2, 3 in it. Numbers 2 is a set with the number 7, 8, 9 in it. And you can see when it prints it out, it actually prints it with the braces. The next exercise illustrates how you can take a list you have already created and make a set out of it. When you print this out, you get in curly braces the list elements that were in the first names list. So you have some functions and methods that you can use with sets. The add method places a new element in the set, and the remove and pop remove an element from the set. So some of the methods that were useful to sets look a lot like the ones we've had before. The length of the set tells you how many numbers are in there. Set1.update set adds the elements from one set to another. So set1 I'm going to take and update it, putting set2 into it. So this adds the elements of what you put in the parentheses to the first one. Set.add is going to add a value. So update updates with a different set. Add puts one element in, one value into the set. Remove will remove the value, and remember that here I don't have to think about it being the first one because there are all of these are unique, so there's only one of each one of the values in the set, and it raises a key error if the value is not found. So we'll talk about how to deal with making sure that we don't get a key error. Set pop removes an element, a random element from the set. So note that this one you don't put anything in there. You don't put anything in the parentheses, and set clear clears all the elements. So we have the length you can update with a complete other set. So putting two sets together here, you can't just add them together. Concatenate, you have to update. And putting one element is an add. Removing one element, that's a remove. And a pop will take a random element. This you could use if you were working with a set of cards, because the cards would be sets, and if you were actually shuffling and then dealing out cards, you'd pop those cards off as you were removing them from the set so that you would know what was left in your stack of cards. And set clear clears all elements from the set. Note that these are methods. The first one is actually a function, the length of the set. The rest of the methods, you can see the dot, update, add, remove, pop, and clear. Be sure to go through the participation activity and take some time actually writing down some of these and understanding what they do, because it's easier if you see some examples. The 3.6.1 challenge activity is just creating and modifying sets. So here they've already made a set, and then we're modifying it. So note that these were the most popular names of 2017, Oliver, Declan, and Henry, according to Baby Names. Now you could look up your year and see what was the most popular names. It's kind of interesting which ones show up as popular. All you're adding here is a couple of lines of code to remove the one that you said name to remove, and then to add the one that you said name to add, and then just print that out. That's all it's being asked for. It's very short. Some of you who are upperclassmen may have seen some set theory in one of your courses. So set intersection, set union, set difference, and set asymmetric difference are different set operations that you can do. Note that these are dots, so that means that they are actually methods for the set. So you might look those over, and then they've got a couple of exercises for you to play with those. In the 3.6.2 challenge activity, they're going to give you a couple of lists. Well, they're not lists here, they're sets. You can tell they're sets because of the braces. So they give you a couple of sets, so that the order doesn't matter here. And then they want you to sort them. So there's this method that you can use, function that you can use on the list to get all the names sorted out. So they should print out the names sorted out. You could already do the male names and the females here if you wanted to kind of see what that looked like. But here they're wanting you to do neutral names that contain only names found in both male and females. So that would be an intersection, and then a set specific names that contains only gender specific names. So that would be the ones that are only in one set or in the other set, but not in both. Now the next section of chapter 3 talks about dictionary basics. So I'm going to have you work through these exercises before the test, but these will not be on the test. So up through 3.6. So chapter 1, chapter 2, and chapter 3's 3.1 to 3.6 will be on the test. So I'll put the rest of this on a separate video.